we are going to use the laws of logs just to expand and condense some logarithmic expressions. And then we're going to get into some juicy actually solving where we actually use the laws of logs to solve what we need to solve. If you look at all of these log problems, we can all assume that the base of all of these are, yes, 10. So I guess somebody didn't feel like putting those subscripts in. So right over here, you have the log of 5 times 3. And if you go to your log property, you should realize that you should be able to write this as log of 5 plus the log of 3. And if you were to do the log of 15 on your calculator, I bet it's going to be the log of 5 plus the log of 3. And if you were to do that, it would actually work out. The same thing down here, again, we can take this and we can write this as a sum. So we can do the log of 3 plus the log of 2 cubed. But we're not quite done yet because we can take this 3 and put it down. There should be a log of 3 here. So this is going to be the log of 3 plus 3 times the log of 2. That's what we mean by fully expanding. So when you have something like this, you want to take that and bring it down because remember, one of your log properties is, log base a of m to the k is equal to k times log base a of m. Okay, this one right over here, because this is raised to the 6th power, the first thing you're going to want to do is bring that down, again, using that property. So this is going to be 6 times the log of 6 over 5, which is going to be equal to, this you can write as a difference, but don't forget the 6 goes to both. So this is going to be 6 log of 6 minus 6 log of 5. Okay? And again, you could always go ahead on your calculators and evaluate that. That if you did this on your calculator and then evaluated this on your calculator, you can bet the farm they're going to be the same thing. So if you want to hit pause and go through 8, 10, and 12, why don't you do that and then come on back to me, okay? So this is telling me that I can go ahead and do this, right? I had to bring the 2 down first, but my final answer should be 2 log of A plus 2 log of B, okay? Again, up here, you can do this where you're going to do the log of X minus the log of Y to the 5th, but you should remember the 5 has to come down. So this is going to be the log of X minus 5 times the log of Y. Now this one's a fun one because this is a triple, so this is going to be the log of X plus the log of Y, and noticing these are all base 10 because it's easier, plus log of Z squared, but I hope you guys are like, nope, got to bring down that 2, so your final answer is going to be log of X plus the log of Y plus 2 times the log of Z. Okay, so this is expanding, so that's how we expand. So when I tell you to expand, you want to go the other way, whereas something like this is saying condense it. So you're going to start off with something like this, but you want to wind up with something nice and neat and clean, okay? So this one over here is interesting because I can write this as 1/3 times the log of 6 because it's the same thing. So now instead of, going from, we want to go from here to here, so therefore this is going to be the log of 6 to the 1/3 power. So this is the condensed form of that because we brought that power up, okay? Over here you have the sum, which means you can write it as the product. So this could be the log of 2 times 11 times 7. And then this one over here, again, this is the same thing as 2/3 times the log of 7, which we can rewrite as, yep, you guessed it, where this is raised to 7 to the 2/3 power, okay? And remember, this is 6 to the 1/3 power. Okay, so these are some problems. So you're going to be doing the odds on whatever I have to tweak over on Canvas. But anyway, so let's go on. Let's do some hardier problems, okay? Let's actually solve these problems out. So you have log base 3 of 8x minus 15 is equal to 4. So if you look at this graph, it's almost as if you're trying to find out where does this logarithmic function intersect the line y equals 4, right? So if you were to look at that, if you were to set this equal to 0, you would have 15/8. So 15/8, what the heck is 15/8? It's a little more than 1, isn't it? Like 15 divided by 8 is 1.875. So if you were to look at this from a graphical perspective, everything shifts over to the right. You're shifting what you are typically over here at 1, 0, which is what a log, if you do log base 3 of x or whatever equals y, and you were to graph that, it's going to be asymptotic to the y-axis, and it's going to cross over here at 1, 0, because log base 3 of 1, from the last video, log base 3 of 1, if we plug 1 in, right, and we solve that, we would basically call that x just for fun, so 3 to the x equals 1, so x would have to equal 0, which is y, we'll call that y, so call that y, so it would have to equal 0. So now this is basically saying you're taking what was typically there and now you're shifting it to the right 1.875. And I'm going to confirm that on my calculator. Log of 8x minus 15. I'm literally doing it on my calculator so I don't screw this up. Divided by log of 3 just to make it really easy. And we're just going to go graph. And yep. So we're going to calculate our 0, and our 0 is in fact at anything after 1 is an issue, right? So let me go to my graph. I'm a hot mess right now. Just a second, calculate. We're going to look for the 0 where y is equal to 0. Forgive me. Where's my cursor? Where'd my cursor go? Nope. Can't be over there. Jumping over here. Yep. Okay, so down here. So that says 1.9346. That's really interesting. Divided by the log of 3. Anyhow, it's like basically saying where does this intersect y equals 4. So I kind of digressed. I apologize for that. So you probably could just fast forward to a hot mess. So if we want to solve this log function, all we have to do is now, because we don't need a calculator for this, by the way, we're trying to find out where this log function intersects the line y equals 4. So we typically call that log equals 4. So you can go ahead on Desmos and find out what it actually does. But it turns out to be, I think, a nice number. So if we write this in exponential form, and if you want to hit pause and do it yourselves, that would be delightful. You would just do 3 to the 4th is equal to 8x minus 15. And the last time I checked, 3 to the 4th was 81, and then 8x minus 15. I'm going to add 15 to both sides. So 81 and 15, I believe, is 96, right? Oh, it turns out to be 12. So this is 96 is equal to 8x. So 96 divided by 8 is, in fact, 12. So we get x is equal to 12. So this point of intersection here is 12, 4. Now, when we're doing log stuff, remember, this inside here is never, ever, ever allowed to be negative. Because remember, 3 to some power is never going to give you a negative number. It's just not going to happen. But what we want to do is we want to confirm, we have to check to see if our answer makes sense. And it's basically saying if we plug x in here, we're saying is log base 3 of 96, because that's minus 15, does that equal 4? So this is log base 3 of, and 96 minus 15 is 81. Is that true? And the answer is, yeah, it is. Log base 3 of 81 is, in fact, 4, because 3 to the 4th power is, in fact, 81. So therefore, the solution to this function is 12. Now, when we move on to something even a little juicier over here, take a look at this. We have log base 2 of x plus 2 plus log base 2 of 3 equals log base 2 of 27. The nice thing is that they're all the same base, which is awesome. And now this is where we want to apply those laws of logs, where in this case, it's important for us to actually want to, you guess it, we want to condense this. So if we condense this, we have log base 2, and we can write this as x plus 2 times 3, right, is equal to 20, log base 2 of 27. Oops, squeeze me, okay, equals, pardon-moi, equals log base 2 of 27. So now we have log base 2 of 3x plus 6 is equal to log base 2 of 27. Well, isn't it true that log base a of m equals log base a of m implies that n is equal to m? Doesn't that make sense? That would be true. So now we can go ahead and just set 3x plus 6 equal to 27. So now we're going to subtract 6 from both sides. That's 21. So now we get x is equal to 7. And now we actually want to confirm that this actually works. Don't forget, you always have to check to see if it works. So if I put 7 in here, which I'm going to do now, I'm going to have log base 2 of 9 plus log base 2 of 3. Does that equal that? And the answer is going to be yes, because I'm going to write this as a product, because log base 2 of 9 times 3 is in fact log base 2 of 27. Okay? Always check your answers. Okay, so if you want to hit pause and try this one on your own, you can. But I'm just going to keep going. So again, I'm going to condense these two right over here. So I can write this as log of, and if I multiply these two out, I'm going to get x squared minus 2x is equal to log base 3 of 10. Now, again, because the bases are the same, I can set these two things equal to each other. So I have x squared minus 2x is equal to 10. And now I have to subtract 10 from both sides because this is now a quadratic. Okay, minus 10 is equal to 0. So now, oh, it's x plus 10. Oh, Charlene, Krista. How did I do that? I guess you guys are probably saying that this whole time, right? So just bear with me. Okay, so this is x plus 10. It's actually going to work out better. So this is x plus 10. So now, if I go back and erase, I'm going to subtract everybody and set it equal to 0, because remember, you got to have that 0 property. So this is, in fact, going to be minus 3x minus 10 is equal to 0. And this is, in fact, factorable, which is nice. It does factor, so it's going to be x minus 5 times x plus 2 is equal to 0. So now we get x equals 5, and we get x equals negative 2. Now, remember, we have to go back into this equation, and we have to test both values. So when we start off with x equals 5, which I will do, I'm going to have 5, hold on. I'm going to go back here, and if you check it out, log base 3 of 5 plus log base 3 of 2, does that equal log base 3 of 15? Okay, so log base 3 of 5 plus log base 3 of 2, does that equal log base 3 of 15? It doesn't look like it does, though. Oh, yes, it does. I'm sorry. No, it doesn't. So if I were to, oh, it's supposed to be 3, not 2. I'm so careless. Okay, because 5 minus 2 is 3, right? But you guys are, again, saying, Schwa, what are you doing here? Schwa's a hot mess, but it doesn't mean that I'm unlovable. Okay, so if you look at this and we condense it, again, it's going to be log base 3 of 5 times 3, which is, in fact, log base 3 of 15. However, when we go to check x equals negative 2, we have log base 3 of negative 2. Plus log base 3 of negative 4. What's the problem with that? Can you have the log base of a negative number? Oh, I hope you're all saying no, right? Because if I set that equal to x, when will 3 to the x equal negative 2 if I write that in exponential form? And you're going to say it never does. So therefore, that is not a part of the solution. The only value that is x equals 5. So that is why you actually have to check both solutions to your problem, okay? Moving on over here. If you look at this is interesting because we have log base 5 of 10x minus 1 is equal to log base 5 of 3x minus 1. When you're in this instance, my advice, get all the logs to one side and all the numbers to the other side. So if I do that, I have log base 5 of 10x, and then it's going to be minus log base 5 of 3x minus 1, whoops, is equal to 1, okay? So, because I'm adding 1 to the other side. So I just rearranged the equation because the thing is I'm going to use my law of logs. And again, I want to condense this. And when you have log of something minus the log of something, you can write it as the log of 5 of 10x over 3x minus 1. And that's going to be equal to 1, right? So we have that. And now we want to go ahead and say, I hope you guys are all saying it, that, wow, I can take this log equation and write it as an exponential one by doing 5 to the 1 is equal to that. So 5 is equal, because it's 5 to the first is 5, is equal to 10x over 3x minus 1. And then when you want to solve this, just throw the sucker over 1 and just cross multiply. So we have 10x is equal to 15x minus 5. And then I'm going to subtract 15x from both sides, and I get negative 5x equals negative 5, and I get x equals 1. I have to do what? Yeah, I got to check to make sure that it makes sense. So if I plug 1 in here, I have, I'll use a different color so we can see it better. So we have log base 5 of 10 minus log base 5 of 3 times 1 is 3 minus 1 is 2, right? Of 2 is equal to 1. So we want to go ahead and condense these two again. So that becomes log base 5 of 10 divided by 2 equals 1. So log base 5 of 5 does in fact equal 1, because think about it, because 5 to the first power is 5. And if you remember, that's a pretty little log property that I showed you the other day. Now, did I do another one of these problems, or did I not? Did I end there? Oh, I think I did. I want to see if there's another one, so hang in there with me, okay? Because I want to see, I thought I saw a juicier one. I guess I might not have put it on there. Nope, we already did that one. Okay, bye-bye. But there was one that I thought I saw that I actually took a picture of that I really want to do with you guys. Nope, that was a cutie patootie. That was a cutie patootie. That was another cutie patootie. This one? Maybe it was that one? Yes. Okay. Well, I'm so glad I found it. All right. If you want to give this one a whirl, go ahead. Again, you have log base equals log base 2 and then plus a 5. So when you're in that position, your goal is to get all your log crap to one side and then the number by itself. So I'm going to move this term over to the other side. I'll change my color to naranja. So we have log base 2 of x squared minus 4x minus log base 2 of 4 minus x is equal to 5. And again, we're going to condense these two, and we're going to do, whoops, log base 2 of x squared minus 4x over 4 minus x, and that's going to be equal to 5, right? So I condense these two using my log property, log base a of m minus log base a of n equals log base a of m over n, right? And remember, these properties go back and forth depending upon what you want them to do. So now here we are, and I hope in your little hearts you're like, you know what, 2 to the 5th, we're going to rewrite this, yes, you got it, is equal to x squared minus 4x over 4 minus x, and 2 to the 5th is, yep, it's 32. I'm going to throw it over 1 because we're going to do a little cross multiplication, okay? And this is 4 minus x. So now I have 32 times 4, that's 68, what is that, 128? 32 times 4, yep. So it's going to be 128 minus 32x is equal to x squared minus 4x. And I hope in those beautiful brains of yours, you're like, we're going to move everybody over to one side and set it equal to 0. So now we have x squared. I'm adding 32 to both sides. So now that's going to be plus 28x minus 128 is equal to 0. So now we can go ahead and factor this, and I triple dog dare you to go off to the side and factor this little sucker, okay? X and 128, let's see. So if I did that, right, 128 divided by, oh, if I did that, look at me, 128 divided by 32, I did 32. So I have plus 32, and then minus 4, it will work out quite beautifully. So I have that. So now I have x equals negative 32, and I have x is equal to 4. What was that? Aha! You got to check to see if they both work. So now what we're going to do is we're going to go back over here, and we're doing log base 2 of now. Negative 32 squared is positive, friends. So that is a positive number. So that becomes 1024. And then minus 4 times the negative, that is another positive. So 4 times 32 is 128. So this becomes plus 128 is equal to log base 2 of 4 minus a negative. You guessed it, is a positive, log base 36 plus 5. So now we have 1024 plus 128, and we get 1152. So I have log base 2 of 1152. I'm going to subtract this little cookie from the other side, okay? And set that equal to 5 because we're going to confirm that all works. And then, yes, I can rewrite it like this. I hope you're all saying that. Divided by 36 is equal to 5. And the last time I checked, 1152 divided by 36 was 32. So this becomes log base 2 of 32 is equal to 5. And then you should all be screaming, oh my God, 2 to the 5th is equal to 32. So therefore, that is definitely a solution. Okay? Now, if you go and check 4, right? If you go and you check 4 and you plug 4 in this time, you have log base 2 of 4 squared minus 4 squared, which is 0. Does that exist? And then the same thing over here, you get log base 2 of 0 plus 5. Well, let's go see. I hope you're all saying log base 2 of 0 doesn't exist in the real world. So, because if you set that equal to 0, right? 2 to the x power, when will 2 to the x equal 0? The answer is it never will. So therefore, that is not a solution, but negative 32 was a solution. So don't be thrown off that just because you come up with a negative answer, that's going to be the one that's not the solution, because you notice that this is a perfect example where the negative value worked out beautifully, but the positive value did not. So here's some instances where we actually use the laws of logs to condense and do what we need to do algebraically to find solutions to these particular problems. I hope you found this helpful, and I'll talk to you soon. You guys rock.